In this lesson we're going to look at the principle of moments, and we're going to apply this principle to a simple situation here where we've got a beam that rotates around a pivot, and in this case the pivot is at the center of the beam. So the center of mass of this beam is positioned at this pivot point. Okay, so what is the principle of moments? Well, we say that if this beam is in equilibrium, that's to say it's balanced or it's stationary, it's not rotating either one way or the other, then we can say this, that the sum of the anti-clockwise moments around the pivot point is equal to the sum of the clockwise moments. What do we mean by that? Well, we have a force Fa, which is positioned at a distance Ra from the pivot point. That will produce an anti-clockwise moment around this pivot point. That's to say, due to this force, the beam will rotate in an anti-clockwise direction, while our force Fb on the other side of the pivot point is acting at a distance Rb from the pivot. That will cause the beam to rotate in a clockwise direction, so that force produces a clockwise moment. So what we can say is that when this beam is balanced, when the beam is in equilibrium, then the anti-clockwise moments acting on it are balanced by the clockwise moments. So let's just spell that out. What that means is that Fa times Ra will be equal to Fb times Rb. So let's just apply this to a simple and typical problem that might come up as an exam question. Okay, so you've got a beam that's balanced, you've got a 20 Newton force acting at a distance of 30 centimeters from the pivot, and you've got some other force acting at a distance of 20 centimeters from the pivot, and to make this beam balanced you've got to find out what that force is. So you just apply the principle of moments. We say again Fa times Ra equals Fb times Rb, and plug the numbers in. 20 times 30 equals Fb times 20, and so you can see straight away the 20s cancel out, it's dead easy that one, and that gives us Fb equals 30 newtons. Now probably there may be problems which are a little bit more complicated than this, especially in the extended papers. Okay, so we're going to have a look at applying this principle of moments to more complicated problems in the next lesson. That produces a clockwise moment around the pivot point. That's to say the beam will rotate in a clockwise direction due to this force,